Okay, so today's video is going to be about how to derive Planck's law, or not, yeah, Planck's law, but how to derive the equation. Because when Planck, there was a equation, there were two equations: number of mod. Okay, for this they used n equal number of mod is n equal 8 pi h frequency f square over c square. Okay, another equation for E, it was kt. K is what? K is Boltzmann constant. Boltzmann constant. Okay, so when they integrated n equal 8 pi and kt, the answer was 8 pi f square over c square kt. This is what they got for this is, if I want to write this, energy density for in terms of frequency and temperature. But if we look at this equation properly, this equation is a disaster. The amount of energy is a lot, it's like infinite, and as we know, nothing in this world is infinite. Nothing in, like, the law breaks, it breaks the law. Nothing is infinite. Also, one more thing, uh, this equation tells us about that the energy of an object, depends on the temperature. But this is wrong, because as Planck said, Max Planck said that energy of object depends on the frequency. So this was suggested by two physicists, but this is wrong. Okay, the one what Max Planck told is the right approach. So then he introduced a new theory known as, and this is what became the groundbreaking discovery for the invention or the creation of what we could now call quantum mechanics. Okay, so this is what created quantum mechanics. As what Max Planck said is, no, energy is not continuous, it has certain frequency, it is discrete. What it is? It is discrete. How it is discrete? It is discrete as this equation, E equal NHF. What does this show? That energy of each object, because I have energy of each object with a certain frequency, will have a integer value energy. N means 3HF, 2HF, 1HF. 1HF we will not write 1. So this is how it will be. It can't have continuous. Can't be continuous. Continuous. Okay. Now this is enough for us to derive the. Now we will derive the equation. Derive the max. Derive the Max Planck's equation. Okay. The equation which describes how energy actually works based on frequency. So first of all, we need to know about probability, okay, because this requires us to have probability. Energy is what? Energy is probability of n. N is what number times En. Okay. And so what is En? Not what is En. What is Pn? Pn is before this. Before you get to know about this, let's add one more concept about a coin. How can we know that a coin will land on tail or head? Whatever the value we get, because rolls once times 2, because half, the chance of it either landing half is 50-50. The chance of landing tails or head is 50-50. It can't be more than 50-50. So using this concept that there is a probability for everything, we will apply this over here, that Pn is actually summation, not summation, yes it is summation, but E would be over here, then P, this one is okay, so n equals 0 of this, means this is showing the summation sign, and this is En of, this is E minus HV, not HV, we will expand it in further on, this is what we should get, okay, over yes, this is what we should get, okay. So then if we combine this with this equation, what we get is I forgot to add one more, E of minus En by kT, okay, and this is actually at the bottom. This is actually at the bottom. Why is it at the bottom? I'll tell you why when I will write the next step. Next step is P of n. When I apply this P of n over here, so I just open the Pn, what it actually is, it is, and over here summation, it has an extra summation over here, so we have, so this is what the extra summation is. So if I write the equation now, it's summation n equals 0 to infinity. If we open this En, E, En and T, if I now divided by again, this is not here, sorry, this will come over here back, yeah, this will come here, so we should be getting summation n to the power 0 E minus En kT. This is what we should be getting, okay, because if this is our first value for the probability of the energy, this En I'll tell later. First of all, yeah, now it's the best time to tell what is En. En is actually E of n is E over here is HV. If I write En, it would be opposite. So it's only E. What E is HV or HV? What was HV? H V is the symbol for frequency in other ways, but we write F frequency. Okay, so if I expand F, yeah, now I not expand F, we just change this HF over here. We change the values of HF over here. Okay, so what we get is let me change the color to white. We get is this equals 0 to infinity. H is what? HV n will not be replaced. E minus again F HF to power to E by KT over summation of E equals 0. So n equals 0 to infinity. Then we have E minus again HF. Remember, HF is energy. It's the, and what is H here? H is Planck's constant. Planck's constant. Okay. So then, let me again. Oh wait, not change the color. N by KT. KT at little K is Boltzmann constant. Yes, it is. And T is the temperature. E is exponential. Okay, so then I expand it again. Okay, before expanding, we will write something. X equal E minus HFN or only HF by KT. Okay. So what does this give us? If I replace X in this equation, it gives me summation and power equal 0 to the infinity HV n. Now E is minus HF and KT is gone, so it will be like this over summation n equal to 0 to infinity. Again this changed to E to the power n, oh sorry, X to the power n. Okay, so this is what we get. Still we don't have the end. Okay, now we'll do the summation. Okay, we'll apply the values to n's, and we will apply like 1 0 1 2 3 and so on. So if I write summation n equals 0 to power to infinity, and if I write HV, or when we're doing summation we don't write it, HV, and so let me put brackets to differ. So n, if we replace n as 0, so this whole thing will become 0. So 0 we don't write. If I replace n as 1, so it will become x, because wait, did I not write x? Sorry, this is actually x. Okay, then x, this will become x to power 1, right? 0, this will give 0, sorry, 0 plus 2, this first is 1, then 2x square plus and replace n with 3, so we get 3x cube and so on plus so on, it's infinity, over, let me just close this bracket, over again this will be removed as we are doing the summation. This will be removed when we are doing summation. Then we get, since there is nothing but xn, what we get? What is xn? Xn is what was xn? Yeah, we'll again replace n with the letters. X to power n is what many people will say 0, but it's actually x to the power 0 is 1 plus x to the power 1 is x plus x to the power 2 is x squared plus x cubed and plus so on. Okay, so when we get this equation, now we cannot write this as our answer. So what we do is we simplify these two expressions. When we simplify these two expressions, we should get, let me copy paste here, this duplicate, this equals to 1 over 1 minus x squared, and the bottom one equals to 1 over 1 minus x. This is what these two equal to. Okay, so when I put these values, now I can put the values back to the equation. I will put these values back to the equation. Okay, so what I will get is hvx over x minus 1, because yeah, that's it. So then when I remove x from the top, I should get x v hv, sorry, again I'm using v, sorry, I'm using v again, f, and wait, f, sorry, v or f, it's the same thing, so I used f. Okay, so when I want to remove x, what I do is I take it, to remove it, then I have to do this. X is removed, and that cost me for this to become 1 by x, 1 by x. And we all know that if I write it in the power form, what will it become? X minus 1. It's the same as writing this. So then again, further on, what I can write, hv over 1 by x, sorry, not 1 by x, we'll change it. Now we have x power 1 minus 1 minus x power minus 1 minus 1. Now again, what is x? We'll bring x this back, this x will bring back. So what we will get, hv over x is what? E minus minus plus hv by kt, not v, hf by kt minus 1. Now this equation, which is the correct way to describe the energy of a certain object in terms of what's different here, in terms of frequency with a certain value which is Planck's constant. This is how the energy is described. Actually, this is how it should be described. Now this plus the equation we had, the number of mod we had, 8 pi of f cube squared over c cube. If we combine this with the new and the most correct correct energy formula, we get 8. Wait, let me use a different color for this one. Let me use purple. We get in the end 8 pi f times f, so f cube h. Let me write h over here, since I cannot write I cannot write h here because it would be wrong, because alphabet comes after number, algebra, over c cube. C cube is what? Speed of light, if I'm right, yeah. Bracket to differentiate E hf by kt minus 1. This is the correct formula to describe what? Energy density in terms of frequency and temperature. This was the start of quantum mechanics. What this showed that energy is discrete, it travels in discrete, and it further on this was the, and there was one more thing. After this, light was known as quanta of light. Quanta of light, as light travels in photons, discrete. This formed, then this was the innovation. This was the stepping stone for Einstein to make what, to discover photoelectric effect. This was what was helped found. Okay, so this was what made quantum mechanics come into existence, because here classical physics finishes and quantum mechanics comes into existence. So let's summarize. We talked about, wait, I will summarize the equation. E is an exponential. It's the graph. When we draw a graph, okay, let me draw a graph for this one. Let me draw the graph for this equation. Wavelength, because this also has wavelength. If I open this f is what, c over wavelength. Wavelength and this is radiation or energy density. Radiation density or means something. Intensity in density. This is how it was made. Okay, these were the visible lights over here. Visible light here. If I make the line for these two equations, where are they? This and this equation. What do I get? If I write this equation, which is these two equations, this is how the lines are, like this and like this. Wait, let me, like this and like this, something like that. I'm not sure. So this was the correct way to describe energy density, because at this point, energy is high. Energy radiation is high. But then after that point, it reached its limit, and then with the increase of wavelength, what happened? The color of the radiation went down to get, then it went to its lowest, like this. This is how the graph for this line should be, like this and like this. Okay, this line went like this way. It went a curve. The line for the equations, it went a curve. It went like this. It went like this. Okay, so then yeah, so this is a reason why we see a color of a metal. Yeah, that's the best example. A metal change from red, blue, then utmost is white. So this is what the color change is about. Wavelength change is the color change. So this is it. Thank you.